I am Mohanlal Perra from Study Guide. Now we are going to discuss a faster method to get partial fractions. First we look into the standard method. We have to build an identity. Then we cross multiply so that the denominators are removed. Then we can equate coefficients of each variable or each power of the variable, or we can use different values of the variable to find the constants. Now the faster method. Still we need the identity. Then we can cover the denominator of the required constant. After that we apply the value which this covered denominator becomes 0. Now the example 1. Convert 1 over x plus 1 into x minus 3 to partial fractions. Now we have to get the identity. That is 1 over x plus 1 into x minus 3 is identical to a over x plus 1 plus b over x minus 3. Here a and b are constants. Now we cover x plus 1 and use x equals minus 1. So we get a equals 1 over minus 1 minus 3, that is 1 over minus 4 or minus 1 over 4. Then we cover x minus 3 and use x equals 3. Now we get b equals 1 over 1 plus 3, that is 1 over 4. So we add minus 1 over 4 times x plus 1 plus 1 over 4 times x plus 3, which should yield to 1 over x plus 1 into x minus 3. Now it is time to start example 2. Here we convert x over x minus 1 into x plus 2 into x plus 3 to partial fractions. First of all, we write x over x minus 1 into x plus 2 into x plus 3 as a over x minus 1 plus b over x plus 2 plus c over x plus 3, where a, b and c are constants. Then we cover x minus 1 and apply x equals 1. So now we get a equals 1 over 1 plus 2 into 1 plus 3, which is 1 over 12. Now we cover x plus 2 and apply x equals minus 2. Then we get b equals minus 2 over minus 2 minus 1 into minus 2 plus 3. Minus 2 minus 1 is minus 3. Minus 2 plus 3 is plus 1. So our denominator is going to be minus 3. So minus 2 divided by minus 3 is 2 over 3. Now we cover x plus 3 and use x equals minus 3, which yield to minus 3 divided by minus 3 minus 1 minus 3 plus 2, that is minus 3 over 4. So now we can add 1 over 12 times x minus 1 plus 2 over 3 times x plus 2 plus minus 3 over 4 times x plus 3 and see whether we get the original expression, which is x over x minus 1 into x plus 2 into x plus 3. Now we have situations where our denominators have powers of n expression. Then we know we have to write denominators starting from the first power of that expression up to the highest power of that expression. We will see this in next example. Now in this example we have 1 over x plus 1 squared into x plus 2. So we have to write a over x plus 1 plus b over x plus 1 squared plus c over x plus 2. Here a, b and c are constants. Now when we use above method, we can get b and c. b is the constant of the highest power of the expression. That is, we have x plus 1 and x plus 1 squared. So when we use the above method, we cannot get a, but we can get b. Now we will see. So we cover x plus 1 squared and use x equals minus 1. Then we get b as 1. Then we cover x plus 2 and use x equals minus 2. Then we get c as 1. Now we can cross multiply as usual in the conventional method. Then we can apply x equals 0, where we get the equation of ABC. When we solve that equation, we get a equals minus 1. Now it is your turn to verify this answer. Make sure when you create partial fractions, add those fractions and see whether we get the original expression. Thanking you. This video is brought to you by Study Guide.